Alrighty, so what we're looking at today, guys, is we're looking at reflections of functions. So that's where our whole function is flipped about either of our axes. So a reflection of a function flips the graph of the function across a line to create a back-to-front mirror image on the other side. In this course, we only study the reflections in the x and the y axes. So the first thing that we're going to look at is a reflection in the x-axis. Is a vertical reflection and its graph of y equals negative f of x. So that means we have the negative out the front of our whole function. So y equals negative f of x makes the sign of the y values of the original function from positive to negative or negative to positive. So we're changing our y values. Do you mean my pen's not working? So then on the number plane, this means reflecting the graph in the x-axis. So the graph of y equals negative f of x reflects the graph of y equals f of x in the x-axis as demonstrated here. So it picks it up and flips it vertically. So we replace y with negative y in our equation of function to reflect its graph vertically in the x-axis. Now my pen's not working. Is we're going to look at sketching the graph of y equals f of x and y equals negative f of x on the same number line for our given functions. So the first function that we have is f of x, there we go, equals x squared minus 2x. What type of function is this going to be? It's going to be a parabola. So our parent function is that it is f of x, or let's just call it y. So our parent function is that it's y equals x squared. So when we see squared, it means it's a parabola. Okay, what are the things that we need to sketch a parabola? We need the turning point. We also need our intercepts. So for our x-intercepts, what we have to do is let y equal 0. So what we'll have is that 0, or our fx has been replaced with 0, equals x squared minus 2x. We can factorise out an x, so we'll have x, lots of x minus 2. So that means we'll have x-intercepts at 0 and positive 2. So if we have an x-intercept at 0 and an x-intercept at positive 2, okay, where is our y-intercept going to be? So our y-intercept is going to be at 0 as well. Okay, because if we have an x-intercept of 0, we're going to have a y-intercept of 0. Okay, our axis of symmetry. So to find our axis of symmetry, we can add our two x coordinates together. Or we can do x equals minus b on 2a. Okay, if you want to do x equals minus b on 2a, it'd be x equals negative lots of negative 2 over 2 lots of 1. So that is just x is equal to 1. Or what you can do is you can add your two x values together. So you can go 0 plus 2, divide them by 2 to find out that x equals 1. Okay, remember either method works here. Now, we want to find our vertex. So to get our vertex, what we have to do is sub x equals 1, so our axis of symmetry, into our function, f of x. So that means we'll have that f of x is equal to 1 squared minus 2 lots of 1. So we get our f of x equals negative 1, so therefore our vertex is at the point 1, negative 1. So we have the point 1, negative 1 there. From here, we can find some key points just by substituting them in. So remember, if you forget how to do all this, you can just use a table of values and your calculator. Okay, so what we will have is that at 3, so we'll have 3 squared is 9, minus 2 lots of 3 is 6. So 9 minus 6 is 3, so at 3 it's at 3, and then it's symmetrical at -1, it's also at 3. If we were to work out where it's at 4, so 4 squared is 16, minus 2 lots of 4 is 8, so it would be at 16 minus 8, which is 8, which is off our graph. So what we want to do is we want to, oh my pen, it's not cooperating this morning, sorry. We want to draw our function going through those key points. Okay, so that is our graph, y equals f of x, which equals our x squared minus 2x. So all we've done so far is sketch the graph of y equals f of x. So what we need to do is now sketch the graph of y equals negative f of x. So when we're finding the negative of it, we are flipping everything about the x-axis. So all of these points are going to flip. So I'm going to sketch my graph in a different colour. So my y equals negative f of x, I'm going to pick a different colour to sketch in, and I'm going to sketch my y equals f of x was already done in blue. So our x-intercepts are going to stay the same. Now every coordinate that we have, so this coordinate here was, oh my goodness, the pen, it was -1, 3. What happens to that coordinate -1, 3 is we multiply our y value by -1. So when we do that, we're going to get -1, -3. -1, -3. Okay, we then have our, so when we times 0 by -1, it stays as 0. That's why our x-intercepts stay the same. Our next coordinate is our turning point, which I should have labelled, which is 1, -1. So when we multiply its y value by -1, we get the point 1, 1. Okay, and then our other coordinate that we have is the point 3, 3. So that will become the coordinate 3, -3. Does that make sense, how we're just changing all of the signs of the y values? From there, we can sketch our reflected function. Okay, so that is then the sketch of y equals negative f of x. So what we did was we multiplied y coordinates of y equals f of x by -1. Okay, that is how we do it. Any questions on that one? No? Okay, our next one that we're going to be sketching is fx equals x cubed. Now, x cubed is what type of function? A cubic, okay? So it is the parent function. So it is the parent function and it's a cubic. So our cubic, we can do a table of values to sketch it, but pretty much it goes through 0, 0, 1, 1, and then 2, it goes through 8. And so then at -1, it goes through -1, and at 2, it goes through -8. If you want, you can draw up a little table of values so that you have these written down if you want, but you don't have to. -8, -1, 0, 1, 8. Okay, and that is for our y equals fx. So our cubic looks like so. Okay, we want to keep it nice and skinny because at 2 it's got to be at 8, and at -2 it's at -8. So it's off our function there. So that is our graph y equals f of x. So then if we were to sketch our graph of our our y equals negative f of x, what we have to do is we have to multiply all of our y values again by -1. Okay, so our key points are the points 1, 1 and the points -1, -1 on this function. But looking at our table, we are just going to be changing the sign of each of them. So it's going, instead of -8, it's going to be 8. Instead of -1, it's 1. 0 stays at 0. 1 goes to -1, and 8 goes to -8. Does that make sense? So what we'll have is we'll have the point -1, 1, 0, 0, 1, 1. Okay, remember our cubic shape like so. And that is our y equals negative f of x. Okay, and so that's a reflection in our x-axis. So it's a vertical reflection there. All right, turn the page when you are ready for our next one. Okay, what we are looking at next is a reflection in our y-axis. So our reflection in our y-axis is a horizontal reflection, and it's of the graph y equals f of negative x. So what we have is we have looked at finding y equals f of negative x algebraically when we're doing our even and our odd functions, okay? And we can see the relationship between f of x and f of negative x by drawing their graphs. Y equals f of negative x changes the sign of the x value of the original function from positive to negative or negative to positive. On the number plane, this means reflecting the graph in the y-axis. We notice that for even functions, y equals f of x equals f of negative x, okay, based on that property that we have already seen and investigated. We have that it's a reflection in the y-axis, and we can replace x with negative x in our equations algebraically. So for each function, we want to sketch the graph of y equals f of x and y equals f of negative x on the same number plane. So our first one here is f of x equals x cubed plus 1. What type of function is that? A cubic, right? So we have that our parent function. So I want you guys to be able to see a function and know what type it is straight away. So our parent function is y equals x cubed, okay, which is a cubic. What does that plus 1 do? Yep, what's the correct terminology and mathematical? Yeah, vertically translates it up by 1, okay? So that means we're picking up, so our f of x function, f of x is y equals x cubed vertically translated 1 unit up, isn't it? Okay, so if we were to look at y equals f of x, we would have our table again, is probably the easiest way to investigate our cubic. Okay, so if we were to see what's happening at our x, when x is 0, our y-intercept is going to be 1 because we're moving it up 1. Okay, so that means we're adding 1 to each of our values compared to where it was for the original function. So for the original parent function of a cubic, at 1 it's at 1, at 2 it's at 8. So for this function, at 1 it's at 2, and for x equals 2, y equals 9. Okay, and then the same thing happens, we're adding 1. So at x equals -1, we need to add 1, so it's now at 0. And at -2, it was -8, so we add 1, so it gets -7. If you're not sure, just use your calculator to help you out there. Okay, so we're moving it up 1, like so. Oh my goodness, pen is not cooperating. All right, so that is our y equals f of x. Now, what we are doing is we are looking at our reflection in the y-axis. So when we reflect in the y-axis, all of our x values are going to change sign. Okay, so what that means is if we just look at it graphically, we have this coordinate 1, 2. We have this coordinate down here is -1, 0. Okay, what's happening is our y coordinates will stay the same, but our x coordinates will change. So if we were to look at y equals f of negative x, right, we're going to have our x and our y's. We're going to copy down all of our y values. They're going to stay the same, but we are going to change the sign of our x values this time. So it's going to go 2, 1, 0, -1, -2. Okay, so our key point -1, 0 becomes 1, 0. We still keep the same y intercept, and our key point 1, 2 becomes -1, 2. And then we can sketch our function from there. I will fix that in a second. Okay, and that is our reflection in our y-axis. So we change the sign of our x values, which means we multiply the x values by -1. Okay, does that make sense? Does anyone have any questions about that? No? Okay, the next graph, what is it? A hyperbola, okay? So this is, the parent function is a hyperbola. Function is y equals 1 on x, which is a hyperbola. Okay, so to sketch a hyperbola, we have asymptotes. So our asymptote is going to be at our line, might do orange, at our x-axis will be our asymptote. Okay, where is another asymptote? So for y equals f of x equals 1 over x minus 2, right? What can x not equal? So x minus 2 can't equal 0, so x can't equal 2. So we have an asymptote at x equals 2. So we need to draw that on. Okay, we can just table of values it, but we can just do it on our graph. So when we do 1 over 3 minus 2, we get 1. When we get 1 over 4 minus 2, we get a half. And when we get 1 over 2.5 minus 2, I think we get 2. Yes, we do. Okay, so there are our, remember we only want our 3 key points with our hyperbola. And then we just draw the rest of the shape in, like so, without all these random horizontal lines that are popping up. So we have that key point 3, 1. Another key point is 2.52, and the other key point here is 4.5. Okay, what we then want to do is we need to sketch in our other quadrant. So when we substitute in 1, we get 1 over 1 minus 2 is at -1. Okay, at 1.5 it's at 2, and our y-intercept, which is important, is at a half. Okay, so then we can sketch using our key points. So that's 1 minus 1. That's the key point of 1.5 minus 2. And 0.5. Okay. So that is our function y equals f of x. Now what we want to sketch is our function y equals f of negative x. Now if we wanted to look at what that is algebraically, we replace our x with a negative x. So that's going to be 1 over negative x plus 2. Okay, which we can take the x out, the negative out the front, so it'll be negative 1 over x plus 2 is what the function is looking like algebraically. Okay, what that means is we have, for this one, that x plus 2 can't equal 0. So that means that x can't equal negative 2. So that asymptote will move and flip to be at x equals negative 2. So we now have an asymptote at negative 2. Okay, that asymptote at y equals 0 is going to stay there as well. Okay, from here we want to pick up our key points and we want to change the x values. Okay, so what is going to happen is our 2.52 is going to become negative 2.52. So that's over there. We then have that 3.1 is negative 3.1 and that 4.5 is negative 4.5. So it's going to become over here. So we have that. I'll just do one key point so that it's not so messy. Negative 3.1. Okay, our other points, we have our 0.5 is going to stay because we don't change our x values. When we times our x value of 0 by negative 1, 0 times negative 1 is just 0. But our 1 minus 1 will be now at minus 1. And at our 1.5 minus 2 will be at negative 1.5 minus 2. So what happens is it goes here. All right, this is where using different colours really helps us to see the difference in it. Okay, and so we have that key point, I'll do this one here, is negative 1.5, negative 2 for that key point. We have that this is y equals our f of negative x. Okay, I believe there is another page, is that correct? Yes. I think we're putting it all together now. So we're doing, if we have all the reflections together, so we have our combined reflections. So what we have, flip the page when you're ready, but we have our combined reflections in both our axes. So if we have y equals negative f of negative x, it reflects in both the x and the y axes. Okay, replacing x with negative x and y with negative y in the equation. And it's also a rotation 180 degrees about the origin. So for each function, we're going to sketch the original graph and we're also going to sketch y equals negative f of negative x. So this first one here, we've already sketched our f of x equals x squared minus 2 of x. That is our parabola from before, from our very first example. So it went through 0, 0, 1, minus 1, 0, 2, 3, 3, and the other key point we had was minus 3, 3. So we can plot, oh my goodness, my pen. We can plot and graph our parabola like so. That's pretty dodge. Okay, so what we want to focus on when we are finding, so that's our graph of y equals f of x. Why is my pen doing this? Okay, what we want to do is for our y equals f of x, we want to write down those key points. So we have minus 1, 3. We have our 0, 0. We have 1, minus 1. we have 2, 0, and we have that point 3, 3. What we now want to sketch is we want to sketch our y equals negative f of negative x. What that means is we're going to change the signs, okay? So we're changing the sign of both our x coordinate and our y coordinate. So that means the point negative 1, 3 will become the point 1, negative 3. So both coordinates change. Okay, so we change the sign of the entire coordinate. Does that make sense? Okay, the next point is 0, 0. Well, that just stays as 0, 0 because when we multiply 0 by negative 1, nothing happens. The next point, it will become minus 1, 1. Then we will have minus 2, 0. And we'll have negative 3, negative 3. So what we're doing is we're picking up, we're reflecting it in the y-axis and the x-axis. So we can then plot those points. So the easiest thing to do is pick those points up. So we'll have our first point is going to be at 1, minus 3. Then we'll have our 0, 0. We'll have minus 1, 1. We'll have minus 2, 0. And then we'll have minus 3, minus 3. And there's our reflected graph with a random horizontal line again. Okay, so then this is our function y equals negative f of negative x. So it reflects in both axes. It's not fun, I know that, but we have to make sure that we know how to do it. It doesn't look nice. Oh. The poor graph, what did it ever do to you? Okay, what we're going to do now is B. So we have f of x equals 2 on x plus 1. Now we haven't done this one before, but we're going to do it really quickly. And it's going to be gross. So what we have is our asymptotes for this one, because this one's what type of function? Hyperbola, right? Because the x is on the denominator. So our asymptote is going to be at x equals minus 1. All right, let's do our 3 key points. So what we're going to have for each part, so 2 over 0 plus 1, so it's going to go through 2s. Then we'll have 2 over 2 there, at negative a half. Let me just quickly get my calculator. Two over negative 0.5 plus 1. It's at 4. Okay, just check what it's at 2 in case it's anything significant. No. Okay, so there's our key points. All right, I'm going to, let's do this one as a table of values. Y equals f of x. Okay, so we're going to have our x values and our y values. Our x values are going to be, I'll write them in a second. Okay, the next one that we need is negative 1.5 is at negative 4. We have that negative 2 is at negative 2 and negative 3. Okay, so starting at negative 3. Negative 3, negative 2, negative 2.5. We're then going to have negative 1. That's where our asymptote is. And then we'll have negative 1.5, 0. Nope, negative 0.5, sorry. Hang on, I've stuffed that up, haven't I? Nope. Have I? Yes. Yes, sorry. Negative 0.5 and 1. Okay, they're all of our values that we have got. So at negative 3, it was at negative 1. At negative 2, it's at negative 2. At negative 1.5, it's at negative 4. We have our asymptote. Negative 0.5, it's at 4. Then it's at 0, it's at 2, and at 1, it's at 1. Okay, I haven't sketched this. Probably need to do that. Okay. So I want to show you how to do it using a table instead of just the actual coordinates. Okay, so what we want to sketch now is our y equals our negative f of negative x. So we are going to look at each coordinate but in table form. So our first coordinate was negative 3, negative 1. We're changing the sign of both of those values from negative. They're both going to become positive, so it's going to be the 0.31. Then our negative 2 is going to become 2, 2. Our negative 1.5, negative 4 is going to become 1.54. At our asymptote of negative 1x, it is going to become 1 and an x there for the asymptote. So the asymptote is flipping from being at x equals negative 1 to x equals 1. Okay, at negative 0.44, that will become 0.4 negative 4. At 0, 2, it will be 0 minus 2. And at 1, 1, it will be negative 1, negative 1. They're all the points that we're going to put in. Okay, so we've changed all the signs from negative to positive or vice versa. So the first thing I'm going to do is put in where my asymptote is going to be, which is at 1. Okay, so then I have my point 3, x value of 3, 1, 2, 2, and at 1.54. And then I have 0.5, negative 4, 0, negative 2, and negative 1, negative 1. So the hyperbola, it stays in those quadrants, okay, because it's just flipped and then flipped. So flipped vertically, then flipped horizontally. So we'll have our y equals negative f of negative x, and our y equals f of x. Okay. The last thing you're going to do on your own, okay, but we have it all set up for you so that it's sort of like you checking in that you understand what's happening with this. So what you're going to do is we have the graph of y equals f of x is shown below. We want to sketch the graph of y equals negative f of x, y equals f of negative x, and y equals negative f of negative x. Now that last one is all of them combined. What's the first one? Is it reflection in the x-axis or the y-axis? X-axis. So that's a reflection in the x-axis. So the next one is a reflection in the y-axis. And this one is a reflection in both axes. So what you're going to do is you're going to pick your key points on your function. So your intercepts are key points, okay? And then you roughly have these other key points as well, okay? What you need to do, if you're reflecting in your x-axis, that means you are multiplying your y values by negative 1. If it's a reflection in the x-axis, you are multiplying your x values by negative 1, and then you're multiplying both values. All right, give that a go yourself.